Hello viewers, in today's class we are going to discuss one important theorem on probability, and the theorem is known as multiplication theorem on probability, right? So this theorem uh, is associated with conditional probability, right? So here uh, in this lecture we are going to solve some important problems on this theorem, and we are not going to prove it, right? So we'll first take the statement of this theorem, and then we will try to solve uh, some problems, right? So here, if A and B are two events associated with a random experiment, right? So if A and B are two events associated with a random experiment, then P A intersection B is equal to P of A times P of B by A. Now here this P stands for the probability of happening of the event A intersection B, and which is equal to the probability of happening of this event A multiplied the conditional probability of happening of B, right, when A has already happened, right? So this term P B by A, it represents the conditional probability, right? This is the conditional probability of this event B when this has already happened. This has already happened, right? Similarly, we have the other expression for the probability of happening of this event A intersection B is equal to the probability of happening of the event B multiplied the conditional probability of happening of event A when B has already happened. So in the first case, we have assumed that the probability of happening of event A is not equal to 0, and in the second case the probability of happening of B is not equal to 0, right? And here this A intersection B, it implies A and B, right? So it means the multiplication theorem on probability, it helps us in computing the probabilities of simultaneous occurrence of two or more events associated with a random experiment, right? So if A and B are the two events which are associated with some random experiment, then the uh, the probability of happening of both the events simultaneously, that is A and B, is given by these two expressions, right? So let us make it clear with the help of one example. Now let us consider this problem. A bag contains 10 white balls, right? 10 white balls and 15 black balls. Now two balls are drawn in succession without replacement, right? Find the probability that first is white and second is black, right? So this problem is based on multiplication theorem on probability. Now let us solve it. So here the bag contains 10 white balls, right? 10 white balls and 15 black balls. Now two balls are drawn in succession without replacement, right? So now we have to find the probability that the first is white and the second is black. So here we'll assume two events, right, associated with the random experiment of drawing two balls from this bag, right? So let us assume the event A, right? the event A represents a white ball. Suppose the event A represents a white ball in the first draw, right? In the first draw. And the event B represents a black ball in the second draw, right? So it means we have to find the probability that first is white and second is black. So here we have AND word. So it means we have to find P A intersection B, right? It means the probability of getting a white ball in the first draw, this is the first draw, and B is the event when the black ball we get in the second draw. So this is the second draw. So if we make use of the multiplication theorem, then we get P A intersection B. We'll use this expression here. So we have P of A multiplied P of B by A, right? So it means once we know the value of P of A and P of B over A, then we can multiply these two quantities to get the required probability. So now here P of A is the probability of getting a white ball in the first draw, right? So how many balls are white? So we have 10 balls, right? So we have to select 10 balls, one ball out of the 10 white balls, and the total number of cases will be 25 C1, right? Because here the total balls are 10 plus 15, that is 25, right? So P of A, the probability of getting this event A is 10 C1 divided by 25 C1, because we have to draw one white ball out of 10, which is 10 C1, and the total number of cases will be 25 C1. Now 10 C1 is simply equal to 10, and we can calculate it by the formula NCR, n factorial over r factorial n minus r factorial, right? So 10 C1 is 10 and 25 C1 is 25, right? So this is the value of P of A. Now P of B by A. Now this quantity represents the conditional probability of happening of event B when A has already happened. It means now we have to find the probability of getting a black ball in the second draw when we have already drawn a white ball, right? So it means the number of black balls are 15. So this is 15 C1, and now we are left with only 24 balls because one white ball has already been drawn, right? So we have 24 C1, right? So 15 C1 is again simply 15 due to this formula, and 24 C1 is simply 24, right? So we have obtained P of A and P of B by A. So now substituting these values here, the required probability of happening of A intersection B is given by 10 divided by 25 multiplied 15 divided by 24. So now we simplify it. So this is 5 3s are 15, 5 5s are 25, 5 2s are 10, and 2 12s are. So here we have 5 3s are 5 5s are 5 2s are, and 2 12s are, right? And here we have 3 1s are, 3 4s are. So this is 1 over 4. So this is the required probability. Now let us take one more problem. So here a bag contains 19 tickets numbered from 1 to 19, right? So we have 19 tickets from 1 to 19, that is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 and 19. So we have 19 tickets, right? A ticket is drawn and then another ticket is drawn without replacement, right? So we have drawn a ticket, then we have drawn another ticket, right? Without replacement. So two tickets are drawn one by one without replacement. So calculate the probability that both the tickets will show even number, right? So here the even numbers are 2 4 6 8 10 12 14 16 and 18. So 1 2 3 4 5 6 7 8 9. So here we have total even numbers are 9, right? And total tickets are 19, right? So now let us take the events. Suppose A is the event when the first ticket is drawn, right? And it shows an even number. So A is the event when we have an even number in the first draw, right? In the first draw. And let us assume B as the event when it shows again an even number in the second draw, right? So it means in the first draw we want to have an even number, and then in the second draw, right, without replacement, in the second draw we should have an even number in the second draw, right? So it means we have to find the probability of A intersection B. It means P, A and B. It means we can also write it as the probability of getting an even number in the first draw and even number in the second draw, right? So now if we apply this rule, then we'll have P of A times or multiplied P of B by A, right? So what is PA? PA is the probability of getting an even number in the first draw. So how many even numbers are there? We have 9 and total number of tickets are 19. So here we have applied the rule total number of favorable cases divided by total number of cases. So we have 9 over 19. Now let us find P B by A. It means we have to find the conditional probability of the event B when A has already happened. So it means we have to find the probability of getting an even number in the second draw when an even number in the first draw has already happened, right? So we can write see here P of B by A means that one even number has already been drawn. So it means the total number of even numbers for the second draw will be 1 less than in the first case. So we'll have 9 minus 1, that is 8. Now we'll have only 8 even numbers to draw. So the total number of tickets will be now 19 minus 1, that is 18, right? So now we'll substitute these two values here. We'll get 9 over 19 multiplied 8 over 18. Now if we simplify it, we'll have 9 2s are, this is 2 4s are, so we'll have 4 over 19. So this is the required probability that both the tickets will show even numbers. Now let us take one more problem. Here we have a bag contains 10 black balls and 5 white balls, right? So we have 10 black balls and 5 white balls, right? Now 2 balls are drawn. Now 2 balls are drawn from the bag, one after the other, without replacement, right? So what is the probability that both drawn balls are black? So here we have to find the probability that both the drawn balls are black. So what we will do, let us assume the event A as getting a black ball in first draw, right? In first draw. And let us assume the event B as getting a black ball in the second draw, right? So it means in the first draw we'll have a black ball, and then in the second draw we'll again have a black ball. So it means we have to find the probability of A intersection B. It means A and B, and this can also be written as the probability of getting a black ball in first draw and black ball in the second draw, right? So FD stands for first draw, SD stands for second draw, right? So now applying this rule, the multiplication theorem will have P of A multiplied P of B by A. Now let us find the value of PA and P of B by A. So PA is the probability of getting a black ball in the first draw, right? So in the first draw we'll have 10 black balls and the total balls are 15, right? 10 plus 5, 15. This is the total number of balls, right? So the probability of getting a black ball in the first draw is 10 over 15, right? Now what is probability of B by A? It means we have to now find the probability of happening of this event B when A has already happened. So it means now we have to find the probability of getting a black ball in the second draw when a black ball in the first draw has already been obtained, right? So one black ball has already been drawn. Now we have to find the conditional probability of the drawing of black ball in the second draw, right? So now we'll have because one ball black ball has already been drawn in the first draw, so we are left with only 9 black balls, and the total number of balls are 15, but now one ball has already been drawn in the first draw, so the total number of balls will be 14, right? So now substitute this value and this value here. We'll have the required probability as 10 by 15 times 9 by 14. So this is 5 2s are 5 3s are, and this is 2 7s are, this is 3 3s are, so we have 3 by 7. So the probability of both the drawn balls are black is 3 by 7.